Before I begin, I need to thank a few people that prepared slides that I have appropriated for my use here today. I'm a big believer in building on the work of others whenever you can, so there are no original slides in my presentation. So thank you, Laura Krager, Dave Skudis, Troy Thompson with ERC, Jesse Clark with Stream Landscape Architecture and Planning, Brian Murphy with Riverworks, and Tyler Roseberg with Icon Engineering. So thanks, guys. I'm going to be providing an update on the progress the district is making on how we approach urban stream planning, design, and implementation. It's an effort that's been underway for a couple of years and includes aspects most of you have heard of by now in some way or another, including the concept of high-functioning, lower-maintenance streams, the 5 elements, and the Urban Stream Assessment Protocol, or USAP. In addition to some of those familiar aspects, I'll touch on an implementation strategy that Laura mentioned that we're working on to help us develop balanced solutions that contribute to thriving communities. All right. So here's my Star Wars theme slide. That's it. Yay. Woo-hoo. All right. So this all started a few years ago because the district wanted to promote the concept of high functioning and lower maintenance streams in our planning studies and design and construction. We had a new hope that we could move our practice beyond a heavy focus on the hydrology and hydraulics. Laura alluded to this earlier. Thus was born the term Heflames, which Dave Skudis thought was funny enough to make a video about, the funny phrase. Well, what was it exactly that led us to recognize we needed to move the practice forward, to get beyond solutions focused so much on hydrology and hydraulics? Well, with the H&H focus, our projects were really about getting the water from point A to point B. Is it moving? There it goes. Thanks, Jesse. And we did a good job of getting the water from point A to point B, and we still do. What we noticed, though, is that a lot of the infrastructure we had put in place over the years was either reaching the end of its design life or was failing for a variety of reasons. The more structural the original approach was, the more it cost to replace. When hard structures fail, it's usually in a big way, and it isn't really maintenance. It's new capital investment. So realizing this, we were very interested in figuring out how we could implement more sustainable and less costly projects. As we started looking for different approaches, we realized stream forms and processes, natural stream forms and processes, provide great examples of systems that can generally accommodate floods without failing and that do some self-repair of damage over time, kind of self-maintaining in some ways. So, hey, great, let's figure out what we can do to better incorporate natural stream processes into the urban stream design to create those more sustainable systems. Again, we're looking for high-functioning, lower-maintenance streams. But what did that mean, right? What does a high-functioning, lower-maintenance stream look like in an urban area? We know what it looks like out in an undeveloped area, but how about urban areas? Well, we needed to figure that out, and we needed to communicate it. So, how's our communication going so far? Can you identify in these photos the high-functioning, lower-maintenance streams? You might think so, but in reality, it's kind of hard to know because it's hard to know if a solution is higher functioning and lower maintenance without knowing its context. Is it in a greenfields development? Are there critical utilities? Is it in an open space or behind people's houses? Does it reflect the values of the surrounding community? Although we couldn't point to something specifically as a high-functioning, lower-maintenance stream, we knew, again, that incorporating natural stream processes was important. So we started the conversation. We wanted people to think about those natural processes, and we really focused on an example that maximized mimicking those processes and forms. And the example that we talked about a lot included factors to consider. bankful channels, sediment transport, geomorphic functions, and so on. So ideally, taking all these things into account would lead to a stable stream that adequately and safely conveys flood flows with a minimal amount of rock, boulders, concrete, right? It's kind of the ideal. Well, this cross-section and others similar became associated very closely with the high-functioning, lower-maintenance streams, which led to an attack of the clones. Now, I don't know if you've noticed, but I've noticed lately many stream projects include a cross-section, something like this, which is great because we get riffle grade control structures. We get soil-wrapped lifts without boulders on the edges. We get connected floodplains and such. So this is great and fantastic when the project context allows it. Unfortunately, we noticed that people began to think that this cross-section, and only this cross-section, equals a high-functioning, lower-maintenance stream. I knew we were doing a poor job of communicating the Heflames concept when I was told that a Heflames solution wasn't suitable for a particular location because there wasn't enough room for that solution. Well, so that just points out we were not communicating the importance of context, particularly in developed areas. So what sorts of contextual things affect our urban projects? Well, we have lots of things. We have development. We have houses pushed right up against our floodplain. We have utilities. We have trails. We have more development. There's the trail. There's more development with its stormwater discharge. We need a bridge to connect things, and so on. So obviously, we don't always have the room to make use of that idealized cross-section. But you know what? Incorporating natural stream processes in an urban area, in an urban setting, isn't easy, and yet it's possible, and it's something we should be promoting as much as we can. Oh, there's a little unicorn just showed up. What about that? So here's an example of a project that incorporates Heflames concepts. Does it totally incorporate natural stream processes? No, it doesn't. But it took them into consideration, and it does incorporate what natural processes it can in this particular context. This is the best that this little creek could do in its setting. But by gosh, it's doing what it can. So in addition to figuring out how to better communicate the high-functioning, lower-maintenance stream concept, we're also, and Laura alluded to this earlier, we're also working on developing an overall stream design and planning approach that'll help us formulate these solutions. It's an approach that will be very powerful when the force awakens with it. So, what is our approach to urban streams? Fundamentally, it's context sensitive. You're going to hear that a lot. And it alludes, again, to what Mickey was talking about. We need to know more about the world that we're operating in, our overall environment, our context. So it's a context sensitive approach. What are the physical, political, and community settings of our planning or design project? And why are we doing this? What's the big deal? Well, it's because our traditional way, although it's been very effective and it's worked and we have an incredibly safe system of stormwater conveyance, it hasn't always resulted in solutions that best balance urban stream design with community goals and needs. Now, how are we going to implement this? Well, we've got multidisciplinary teams looking at our projects through the lenses of the 5 elements, which reflect stream functions. Now, I don't know about you guys, but a long time ago, when I first started coming to these, it was almost exclusively our engineering partners. But now we have such a multidisciplinary mix that includes ecologists, landscape architects, planners, et cetera. So the people in this room are recognizing recognition of that multidisciplinary approach. Whoop. Okay. Ultimately, our urban streams exist in communities that we are protecting, and our work should support those communities in their efforts to thrive and to increase quality of life. We're working to accomplish that through those 5 elements, First with the community values, hydraulics, hydrology, geomorphology, and vegetation, which again, we use to define and consider what makes up a high-functioning urban stream system. This approach ensures holistic planning, design, implementation, and long-term management of our streams. So Laura touched on this project. I'll just go through it quickly. This is, again, the River Run project. This is the pre-project condition. It's the project on the South Platte. Hey, it's conveying the flows very well. It's doing its job, and it's a success when looked at through the H&H lenses, although apparently there was a drop structure that needed some work. Well, what happened when the team stretched a bit and took the time and the effort, time and effort? It's something that's sometimes we're loath to give because we're in a hurry, we have budgets and schedules, but the time and the effort when we give it to consider other elements results in multi-dimensional projects that improve the quality of life of our community and moves water from point A to point B. So this all sounds great, right? Finding ways to maximize the quality of life in our communities while reducing risk of harm and injury. Well, one thing when we're doing this, though, is to be sure to improve the quality of life for everyone, including communities that have been historically overlooked. Obviously, quality of life varies depending on many factors, but where you live makes a huge difference. This is a South Platte River through Denver with neighborhoods shown with colors coded by a condition assessment done in the 1930s. This was a standard practice that helped banks sort of decide where they were going to lend their money, people were going to invest their money. So you can't read the legend, but the green neighborhoods are best, blue, still desirable, yellow, definitely declining, these are their terms, and red was hazardous. Not undesirable, but actually hazardous. So those red-lined communities, you've probably heard that term before, redlining, those communities, those neighborhoods, the people that lived in those neighborhoods were deliberately deprived of investment capital, which adversely affected the people living there. Well, guess what? Blink, there's the floodplain. Important parts of our work occurs in communities still feeling the effects from past land use practices and social dynamics. We need to recognize that and embrace the chance to work with these communities to improve their quality of life in ways that are meaningful to them. We need to listen to them. What are their values? What's meaningful to them when we're coming up with our design solutions? So this mindset has obvious connections to the principles of diversity, equity, and inclusion, which are being stressed so much in public and private arenas these days, rightfully so. With its community values element, the urban stream approach has DEI aspects built right into it. And now, other than being just the right thing to do, Laura has made the point that in many conversations she's had at the local and national level, being able to demonstrate a project's connection to DEI may actually facilitate funding, including from the Infrastructure Investment and Jobs Act funding. So again, though, the key is to intentionally and explicitly make these connections between our projects, their context, and the diversity, equity, and inclusion aspects of it. And the great outcome is when we engage with our communities, when we actually listen to them and reflect their values and acknowledge what they care about. They become great stewards of our projects and advocates for our work. So it's worth the time and effort to get that return on our investment. So by now you're probably all saying, well, that's all well and good, but how can we integrate all these concepts into our projects? We're engineers, we're trying to solve problems here. So how can you guys help us figure this all out? Well, we've got you covered. Okay, well, we don't really totally have you covered because there aren't any cookie cutter recipes or flowcharts or, spec sheets, et cetera, to help with this stuff. This approach to urban streams challenges us to not do things the same way every time. What is the context? It differs every time. So we need to come at every project with a fresh eye, bring people to the table with diverse takes on the 5 elements, especially those that we personally are not terribly familiar with. And we need to be clear how our project is going to improve quality of life in as many ways as possible. And yes, it's a lot. It is a lot. However, we're hoping that the steps of this implementation strategy shown here will help us guide us through this process a little bit. And I'm not going to go over each of them because you guys can read. But I will say that the first couple of steps, the understand and define, those are ones we often don't spend enough time on or skip altogether. As Laura said earlier, we like to get to the solutions, darn it. We're problem solvers. But we come to our project sometimes with a solution in mind that may not be what the community needs or wants or that particular context is appropriate. So everything I've discussed so far has been kind of arm-wavy, community values, Heflames, strategy. Well, how does this all really translate into our day-to-day? And that's where the urban stream assessment protocol comes into place. Things get quantitative there. And the USAP allows us to determine baseline functions, quantify functional lift from baseline to proposed conditions, and determine if we're meeting our project goals. So the urban stream assessment protocol right now, we've identified what functional aspects we're considering, and those are the 5 elements: community values, hydrology, hydraulics, geomorphology, vegetation. We've come up with indicators for the elements, and I'll show you those. And we're currently in the process of doing pilot projects, and I'll go through one of those as well. But the USAP is pulling together, and as Laura alluded to earlier as well, we're including data eventually into the Confluence program. So we've got our 5 elements. We broke those elements down. We tried to distill them down into their essence. And again, I'm not going to belabor this slide, but we really wanted to understand what each of the functions meant in terms of what it does for the stream itself, what its importance is to society, and what our ultimate management goals are for each of those elements. Again, for each of the elements, we had to come up with some indicators. What were we looking at to determine the level of function? And each indicator has its own, each element has its own various indicators that reflect on its specific aspects. Hydrology, you're familiar, runoff production, flow regime. Geomorphology has stability, morphology, etc. So we took those indicators and added measurable metrics. This is what we collect the data on, and we collect the data at different scales depending on what we're looking at. Planning maybe is at a watershed scale, corridor, and then we have the reach scale. And the data on each of these metrics allows us then to create a score for our project. And I'm going to go through a quick example here. This is the Big Dry Creek through a South Suburban Park and Recreation District golf course, and this is a project that Icon, Engineering, Valerian, and Great Ecology worked on. And they kindly piloted applying USAP to this project. And what they did was originally break the stream reach into, or the overall project area into different reaches. And they brought into the team, they included the maintenance people from the get-go. They included the golf pros that work on the course day to day. And of course, they included the golf management as part of the team with coming up with the scoring and deciding what was appropriate to them, to the actual users of this site. And they scored it all, and it came up with this crazy table. What you can see, though, maybe, is at the bottom, there's the summary score for each reach. And you'll see that, like, reach 11, the one on the far right, is green, so maybe that one's functioning pretty well. Whereas, like, reaches 1 and 2, they're red. Maybe those are areas that we should provide a little bit more emphasis on, and we wouldn't have necessarily known that without these scorings. So once they took the scores and they developed alternatives, they applied the USAP to those alternatives, and they quantified the potential lift for each of the alternatives and selected among them based on, again, those trade-offs that Laura talked about, They knew what the trade-offs were because they quantified them. There's a little dial, doesn't show great, on the right-hand side, the little dial that goes from red to green. There's one arrow that shows the existing, the E, and there's the little arrow that looks at it and shows the proposed, which moves the dial a little bit, but it's quantified. So they were able to look at the different alternatives, mix and match to find the best lift for the best dollar value. And in fact, because they're engineers, they calculated the cost per 1% increase in stream function. And you can see some of the, at 14,000 some odd dollars in Reach 8, it costs that much to get 1% reach lift. Is it worth it? Maybe. But now you have these data to help you make your decisions. It's very transparent for everyone to see and understand how you got to your decision making. So that's a real important piece of the USAP, is just being transparent and deliberate in how we reach decisions. And we can explain this to the public much more easily and to the stakeholders. So to kind of wrap up and summarize, these urban streams, again, it's all about context. We're really focused on including our community, looking at projects through the 5 elements of stream function that reflect the context that we're working in. We're trying to develop and working with you, and we always appreciate your feedback, developing strategies and tools to help us move this forward. And ultimately, we're looking to improve the quality of life for everyone in our community, the millions of people whose lives we affect. And we want to just really bring them into the picture a little bit more consciously. And with that, there you have it. A high-functioning, lower-maintenance stream system in an urban area. So thank you very much. Appreciate it.